Good day, all viewers. I am Matthew P. Albania, and these are my partners,
Olila and Poseidon Laguador.
Today, we are going to tackle principles on similarity in right triangles, and we are going to focus on Principle 2. But before we proceed to Principle 8, let's have a simple recap on triangle, similar triangles, right triangles, and the hypotenuse.
Triangle. Triangle is also called trigon, and it is a polygon with 3 sides and 3 angles.
Similar triangles. These are triangles with proportional sides and congruent angles. Right triangle. The right triangle has one right angle and 2 acute angles which are complementary to each other. And the hypotenuse is the longest side of the triangle. Now, let's proceed to Principle 8.
Principle 8. The altitude to the hypotenuse of a right triangle divides it into 2 triangles which are similar to the given triangle and to each other.
Based on this diagram, it clearly shows what is stated in Principle 8. Now, we can see that there is an altitude drop from the vertex A to the hypotenuse of the original triangle. And in result, it divides it into 2 triangles which are similar to the original triangle and to each other. Now, let's move to the corollaries of Principle 8. Corollary 1.
The line of the altitude drawn to the hypotenuse of a right triangle is the geometric mean between the lengths of the segments of the hypotenuse.
Now, based on these diagrams, we can create a proportion between the altitude drawn to the hypotenuse and the segments created of the hypotenuse. Now, the proportion created is dA over BD is equals to DC over dA. By cross multiplication, we can get the equation dA squared equals BD times DC. By simplifying this equation, the resulting equation will be dA equals the square root of BD times DC, which is the formula of finding the length of the altitude. Now, corollary 2.
Corollary 2. If the altitude is drawn to the hypotenuse of a right triangle, then either the length is the geometric mean of the hypotenuse and the segment adjacent to the length.
Now, basing on corollary 2 and these diagrams, we can create a proportion between either of the lengths and the hypotenuse and the adjacent segment of the hypotenuse. Now, the proportion created is AB over BC is equal to BD over AB. By cross multiplication again, an equation will be AB squared equals BC times BD. Simplifying this equation will result to the equation AB equals the square root of BC times BD. Same goes with the other leg. Now, for the other leg, the proportion created is AC over CD is equal to CD over AC. Again, by cross multiplication, the equation will be AC squared equals CB times CD. And simplifying this equation will result to AC equals the square root of CB times CD.
Proceed to some exercises applying Principle 8. Given a right triangle ABC, an altitude is drawn from vertex A to side BC. If BD is equal to 5 and TC is equal to 4, find the value of the legs x and y. Based on corollary 2, in order to find the legs, which is x and y, we need the value of the adjacent side to the legs and the value of the whole hypotenuse. Now, to find y, we need, just like stated in corollary 2, we need to find the adjacent side to the leg, which is 4, and the value of the whole hypotenuse, 9. That follows this equation, y is equal to the square root of 4 times 9. Simplifying this equation, y is equal to 6. Now, let's proceed to x. Just like y, we need to find the adjacent side of the leg and the whole hypotenuse. As follows the equation, x is equal to square root of 5 times 9. Simplifying again, x is equal to 3 square root of 5. An altitude is drawn to the hypotenuse BC. Find h if BD is equal to 9 and DC is equal to 16. Based on corollary 1, in order to find the altitude, we need to find the value of the segments of the hypotenuse created by dropping the altitude. That follows the equation h is equal to the square root of 9 times 16. Simplifying this equation, h is equal to 12.
Now, what if variables are introduced on exercises applying principle 8? So, an altitude is drawn to the hypotenuse AC. Find x and BD. So, based on corollary 1, that in order to find the altitude, you must find the geometric mean between the segments created by dropping the hypotenuse. So in this problem, the equation will be x plus 1 squared equals x minus 2 multiplied by 3x minus 3. So simplifying the equation will be x plus 2 squared plus 1 equals 3x squared minus 9x plus 6. By transposition, the resulting equation will be 2x squared minus 9x plus 5. By factoring, the factors will be 2x minus 1 and x minus 5. So, since this factor is an extraneous solution, we will use x minus 5. So, 0 equals x minus 5. So, the value of x will be x equals 5. Substituting the value of x to these terms will be 3 times 5 minus 3 equals 12. 5 minus 2 equals 3. And 5 plus 1 equals 6. So the value of PD, which is the altitude, is equal to 6. In this problem, we need to find x and z. So, in order to find x, we can use the equation x plus 1 squared plus x minus 2 times 3x minus 3. So, simplifying this equation will result to x squared plus 2x plus 1 equals 3x squared minus 9x plus 6. By transposition, the equation will be 2x squared minus 11x minus 5. By factoring this equation, the factors will be 2x minus 1 times x minus 5. So, this factor is an extraneous solution, so we will use x minus 5. So, x minus 5 equals 0. So, by transposition, x is equal to 5. To find c, we need to apply what is stated on corollary 2, which is the leg, it is the geometric mean between the side adjacent to the leg and the whole hypotenuse. So the equation will be z is equal to the square root of 3x minus 3, which is 3 times 5 minus 3, which is 12, and x minus 2, which is 5 minus 2, which is 3. So z is equal to the square root of 12, which is the leg adjacent, which is the side adjacent to the leg, and to the whole hypotenuse, which is 15, due to the sum of 3 plus 12. So the value of say will be 6 square root of 5.
Now, given another problem, in triangle ABC, BD is equal to 8 and BC is equal to 10. Now, we are asked to find x, which is a segment of the hypotenuse of the original triangle, and y, which is the altitude drawn to the hypotenuse. Now, according to principle 8, BC is equal to the square root of BD and the whole hypotenuse. Now, we can write that in an equation where BC is equal to BD times BA. And that would be equal to 10 is equal to 8, is equal to the square root of 8 times x plus 8. By simplifying this equation and removing the radical, this would be equal to 100 is equal to 64 plus 8x. By means of transposition, 100 minus 64 is equal to 8x. Now, 36 would then be equal to 8x. Divide by 8. X would be equal to 4.5. Now, given the value of x, we can now solve for the altitude drawn to the hypotenuse. Now, y is the altitude drawn to the hypotenuse. By putting it in an equation, y would be equal to the square root of BD and AB, which are the segments formed by dropping an altitude to the hypotenuse. This would be equal to y is equal to the square root of 8 times x. Since x is equal to 4.5, we can say that y is equal to the square root of 8 times 4.5. Then y would be equal to the square root of 4 times 4.5 is 36. Then y would be equal to 6. Now, from the previous examples I have given, we are only asked to find a segment of the hypotenuse and the altitude. Now, we are asked to find the altitude, another segment, and the length. Let us first find x using corollary. By means of corollary, BC would be equal to the square root of BD times the whole hypotenuse, which is AD plus BB, or BA. Now, BC would then be equal to the square root of BD, which is 8, times BA, which is 8 plus x. Now, let us multiply. BC will be equal to 64 plus 8x. Since BC is equal to 12, we can remove the radical sign by squaring 12. That would be equal to 144 is equal to 64 minus 8x. By means of transposition, we can remove 64 from the right hand side and move it to the left hand side. 144 minus 64 would be equal to 8x. 144 minus 64 is 80. 80 is equal to 8x. Divide both sides by 8. X would be then equal to 10. Now, moving to the next equation. Let us find y. Again, with corollary to, y is a length. Therefore, y would be equal to the square root of the adjacent side and the whole hypotenuse. Now, given this equation, y is equal to x times BD plus x. Then it would be y is equal to BD is 8 and x is 10. Then the square root of 10 times 8 plus 10. Y would then be equal to 10 times 18. By multiplying 10 and 18, we would get 180. Y would then be equal to the square root of 180. By factoring this, y would be equal to the square root of 2 times 5 times 2 times 9. Now, simplifying this and removing the radical from the other factors, y will be equal to 2. Since there are two number 2's, that would be equal to 1 if we are getting the square root. And the square root of 9 is 3, so 2 times 3 is 6. Since 5 is not a perfect square, we will leave it as is. Then y would be equal to 6 square root of 5. Now, finding z. For the last equation, z is the altitude. So, by corollary 1, z is the geometric mean of the two segments, BD and AD, or x. Now, z would be equal to the square root of BD times x. Z is equal to the square root of BD, which is 8, times x, which is 10. Now, z would be equal to the square root of 80. Factoring 80, we would get z is equal to the square root of 4 times 4 times 5. Now, since there are two 4's, by getting the square root of 4 times 4, we would get 4. And since 5 is not a perfect square, we leave it as is. Therefore, z is equal to 4 square root of 5.